Hello everyone, how are you doing? I hope you're doing well. Welcome to this video. This is the video part number 7 from the test-driven development video series, and if you didn't watch the video part number 6, you should watch it at first and then watch this video. Okay, what's on the agenda in this video? Same as the last video, today we are going to complete the Soundex class implementation through test-driven development. But before that, don't forget to check out the session 7 branch. Alright, open up the Visual Studio Code and on a status bar, click branch button and session 7 branch. What we have test driven so far results in the Soundex class to encode the first letter of the word. But in this video, we want to test drive encoding multiple characters in the tail of the word. Okay, let's do it. Let's implement a new test case. Test f macro Soundex encoding should replaces multiple consonants with digits. Same as the previous test case, we need an assertion. We can copy that and pass a new input to encode function, and we expect A234. Okay, let's run the test cases to ensure it's failed. Alright, the new test case is failed. Let's implement it. How we can pass this test case? A simple solution would be iterating through all but the first letter of the word and encoding each one at this function, at this point. But I think our code isn't quite structured in a way that easily supports that. Let's restructure the code. But before that, remember, in test-driven development, you should do one thing at a time. When writing a test, don't go off and refactor, and don't refactor when trying to get a test to pass. And remember, combining the two activities or two steps will waste your time. Alright, to refactoring, comment out this new test case. We can also disable a test case through an expression in Google Test. We can do it through disabled expression at the beginning of test case name. Let's run test cases again to ensure it's disabled. Okay, as you see at this point, we have one disabled test case. Okay, now we are going to focus on refactoring activity and rework on our solution a little. Take a look at the Soundex implementation. At this point, I think we should pass the tail of the word rather than entire the word to the encoded digits. Okay, let's do it. I'm gonna write a function which is called tail, and we can implement it at this point. Instead a string tail it should takes an input word and we can do it through substr function. Okay, passing only the tail of the word should simplify the code. We'll need to iterate through the letters to be encoded. Okay, let's refactor the encoded digits function. It also allows us to use a couple of string functions that help clarify what the code does. Like at this point, we can use if void empty function. If it's empty, it should return necessarily a string. We can move this expression to this point. Okay, and also at this point we can use the front function. We can also remove this if statement. Run test cases again to make sure all of the test cases are passed. Okay. That ends the refactoring activity. Okay, back to the test case and enable the last test case we have just written. Okay, run the test cases again to make sure it's failed. Alright, the new test case is failed. As I told you before, we can pass this test case through a loop, a range-based loop. We can iterate on void and we can encode every letter through encode function. Finally, we can return the encoding variable. Alright, let's run test cases again to make sure it's passed. Okay, what's wrong? It's failed. Okay, what's wrong? You know, as you can see at this point, it seems we don't have a conversion for the last letter, I mean L, and it would be 4. Okay, take a look at the encoding table. Oh, I got that. I made a mistake at this point. I misspelled a letter. It should be L. Let's run test cases again. Alright, all of the test cases are passed. Let's refactor it. We have added this range-based loop or for loop, and I think we don't need this guard anymore. We can remove it and run the test cases again to make sure all of them are passed. Alright, we have used a new kind of for loops at this point. I mean range-based for loop. If you don't know anything about it, don't worry, we will tell you about it at the end of this video. Okay, back to the Soundex specification. Take a look at rule number 4. Rule number 4 tells us the Soundex code must be 4 characters. We could test drive it. Let's add a new test case for this new specification. Sorry, test F Soundex encoding should limit length to 4 characters. That's enough. We need an assertion, same as previous test case. We should pass a new input. The new input length is more than 4 letters. And what we expect the length of output, it would be 4. Alright, let's run the test cases to ensure it's failed. Okay, the new test case is failed. And what's wrong? As you see at this point, the code throws an exception when Google Mock runs this new test case. But no worries, because our test tool, Google Test, traps any exception and reports a test failure, and also it continues running any subsequent test. Okay, what was that exception? It's basic string mcreate. Okay, I don't want to bore you with all the details. If you just googled up about this exception, you will find it's because of constructing a string larger than the maximum allowed size. It's because of this point. When the length of code exceeds max code length, this variable, zeros needed, overflows with a value that makes a string constructor unhappy. Okay, let me tell you something. Did you notice that? Actually, TDD fosters an incremental approach that makes it easier to resolve problems, because TDD exposes problems as soon as you create them. We didn't need to debug to pinpoint our problem. Just a glance at a backtrace or terminal was all we needed to find out the problem. Okay, for our solution to the problem, we could fix the zero path function, or we could fix the encoded digits, this function. I think fixing this function, it would be better. Okay, how can we fix this function? I think we could break out the loop once encoding gets filled with encoded digits. Okay, let's do it. If encoding length is equal to max code length minus 1, we can break out the loop. Break. Alright, let's run test cases again to make sure it's passed. Alright, what's wrong? I misspelled this variable, max. What's wrong with my IntelliSense? Can copy the variable, max code length. Okay, I misspelled this word. Let me fix it. Max code length. Alright, let's run the test cases again to make sure all of them are passed. Okay. The next step, refactor the design. The new statement that we have added doesn't clearly and directly declare its intent. Do you agree? Okay, we can extract it to the new intention revealing function, and we could call it is complete. The return type of function would be a boolean, is complete. It should take a string encoding and we can move this expression to this point. Alright, and we can call this function at this point. Alright, let's run test cases again to make sure it's passed. Alright, we're done. Back to the Soundex specification. Take a look at rule number 1. It says to drop all of these vowel-like sounds. Okay, for lack of a better name, I refer to these as vowel-like because it also includes H and W and Y. Okay, let's test drive it. Test F macro Soundex encoding should ignores vowel like letters. Sorry, I misspelled ignore. We need an accession. Can copy the previous one. Okay, now I can pass a new word. B-A-E-I-O, all of the vowel like, U-H-Y, and now real word. CDL, and what we expect it return B234. Okay, let's run the test cases to make sure it's failed. Oh my goodness. I'm really excited right now. What's wrong? It's passed. Oh, I got it. The test passes without us adding a leak of production code because encoded digit function answers an empty string, at this point. Answers an empty string if the letter to be encoded wasn't found. Okay, any vowels thus encode to the empty string which gets harmlessly appended. Okay, let me tell you something. When a test case that passes with no change to your classes, you should ask yourself, what I've done differently? Sometimes it's a clue that refers to deficient code. And if a stream of subsequent tests continues to pass, consider reverting your effort. You're likely taking too large steps. Okay, we're coming to the end of this video. Now I'm going to play a video from CPPCon 2016 about rangeful.
Okay, I just want to talk a little bit of rangeful. Everybody knows it, I guess. Everybody's seen it. Everybody loves it. It's all rangeful, and actually, I see that code often, and actually all the objects, right? So it's really bad. Don't do that. If you ever see that code, rather replace it by something like that. If you insist by that, fine. Right? This is the way I would write it. It's constant in the right place. If something actually changes things, you just put a reference on. That's fine as well. And then there's actually, in theory, the range may produce all values, in which case you may want to have something like that. And then I see people, when they have came to that, to do that. This is really bad. What you do over here is you basically, again, accidentally all the objects. You basically destroy everything. This is like trampling on kittens, right? You don't do that. Don't trample on kittens. So basically, auto-ref never is an R-value reference, pretty much. It is, well, it may be an R-value reference, but you don't know. It is actually something called a forwarding reference. So just quickly, so that people understand what that is, forwarding reference happens also not just with auto, but also if you have a t-ref and t is deduced, it's a forwarding reference. These guys behave kind of funny. If I have a mutable L value and I bind it to an R value reference, I could have written the declaration as well as indref. So it may be actually an indref. And actually, if you try to move these guys, you actually destroy the guy you probably want to keep. For int, it doesn't matter, but if it had been a string, it would be bad. Likewise, if I have a constant and bind that to a auto-ref, I could as well have written in constref. So it's again an L value. And then the other case is over here we actually have a temporary, so it actually deduces a temporary, and it's fine. So that's equivalent to kind of that. And this guy could have been moved. Okay, now a little bit something which people may not be aware of. There's actually an upcoming change in C++ 17, which I'm actually personally very excited about, and that is, this is how range-based for is defined in the standard. Like these blue and white blobs are basically verbatim replaced in the code, and then there's a little bit of scaffolding put around. The thing which is kind of awkward in that is this yellow stuff over here. Auto IT equals begin and R, and end of is end of R. The thing which is bad is it makes the begin and the end the same type. And C++ 17 will change that to basically do that instead. It's a really small change, right? Auto just as an extra auto. So the begin and the end can be different types, so which effectively means the begin can be an iterator and the end could be a sentinel. So you can actually do sentinel stuff and you don't have to play around with something like, oh, am I at the end? Am I at the end? Are we both at the end kind of logic. All right, that's pretty much all I wanted to talk about, so thank you very much.
Okay, that's all we have time for this video. In the next video, we will try to complete the Soundex algorithm implementation through TDD. I hope you enjoyed it. Thanks for watching us. See you soon.